Hey everybody, Mr. Kunkel here again. Today we're going to continue talking about polynomial functions and how to kind of write the equations or how to draw a graph based off the roots. Today we're really going to focus on writing equations. That's probably going to be most of our focus ending out this little bit of our unit. So let's take a brief review. Let's say we have a graph. We have a point -3 and we have a point +4. And say you have a graph that comes through those points like that. Well, let's think about what we know. We know this is an even degree because it is increasing on this side and decreasing on this side. And since it is increasing here and decreasing here, we know this is a negative function. And then the last thing we see this goes to the point -3 and crosses our x-axis at 4. So we know our roots are x equals -3 and x equals +4. So let's rough out a rough estimate of this graph. Let's say our function is f of x equals negative, and we're going to plug this in now. We're not always going to write a. And then this is going to be x plus 3. Remember, we take the opposite sign of our root. And then x minus 4. We didn't talk about the a last week. I forgot to bring that up. Really, what we need to really define exactly how this graph behaves, we would need one more point on that graph. And then we could plug that in for x and y, and then we could get a more accurate value for our leading coefficient, this a. But for now, this is really a pretty good rough estimate of our graph. So today, what we're going to talk about is we're going to expand. We're going to talk about multiplicity of roots. And what does multiplicity of roots mean? So let's think about that for a minute. Let's look at two graphs. Let's look at f of x equals x squared, and let's look at f of x equals x cubed. What does x squared look like? Well, we know x squared comes down, passes through point 0, 0, just touches our origin and continues up. What does x cubed look like? Well, we know x cubed looks something like this, where it just passes through our origin. So let's think about, remember we said if it's x squared, remember what we talked about last week was we expect it to pass through our, if we have, x squared says we have two roots. Let's organize that thought. X squared says we have two roots. And if we have two roots, we expect our graph to pass through the x-axis twice, based on what we said last week. Well, this is where we come into multiplicity of roots. Let's say we set this equal to 0. X squared equals 0. All right, let's think about this a different way, so we can really get a good. Let's think about if we were to factor x squared. If we were to factor x squared, we would get x times x, right? Set each of those equal to 0. We get x equals 0 and x equals 0. So x squared does in fact have two roots. They are both 0. We have a multiple, this is a multiple root. This is what we call a double root. Hopefully this down here is still showing up on our camera. Yes. This is a double root. So a double root means if you ever have a double root in a graph, what happens is your graph will come down and touch the x-axis at that double root. So anytime you see a graph come down and just touch the x-axis, that means you have a double root at that point. That means that root occurs twice. So let's look at an example. If we had a graph, let's say this is -3 again, and you have a graph that comes down and just touches there and continues up. Well, we know this is f of x equals x plus 3, because our root is at -3, so we use the opposite sign. And since this is a double root, it's just x plus 3 squared. Or you could say x plus 3 times x plus 3, x plus 3, which would simplify into x plus 3 squared. So a double root means, all it really means, all we need to think about whenever we're thinking about these roots, is it comes down and touches our x-axis and continues up. What about here, when we have f of x equals x cubed? Well, if we were to factor out x cubed, we know that it would be x times x times x. If you set each of those equal to 0, you would just get x equals 0, x equals 0, x equals 0. So this here is what we call a triple root. A triple root occurs whenever our graph crosses the x-axis in this kind of, in the same fashion as it would with x cubed. Now, in the grand scheme of things, really, any even, if you ever have an even multiple of roots, if you have a quadruple root, you'll see this. But for our purposes, we're just going to be working with double and triple roots. If you had 5 roots that were all the same, it would cross our axis similar to this. But for our purposes right now, we're not going to go beyond triple root. So let's think. Let's combine these two and look at a graph. Let's say we have the point -4 and we have the point 2. So say our graph comes down, touches at -4, comes up, we curve down, we come to 2, and then we do kind of a little zigzag there. What do we know about this graph? Take a moment, pause, think about it. Alright, so what do we know? We know that we are decreasing to here and we are decreasing here, so we know this is an odd degree. And then we know that similar, if it's decreasing, we know this is a negative function. And if it's an odd degree, that means we need an odd number of roots. So let's think about this. So what did we say here? We said we come down and we touch on a point on our x-axis and continue up. That means we have a double root. So if this is a double root, we know we have a root at x equals -4, and we write dr for double root. And we notice that our graph comes here and does that the same pattern as x cubed through +2. So we also know x equals +2 tr for triple root. If we were to write this out, our function would be f of x equals x plus 4, remember, flip our sign, x plus 4, x minus 2, x minus 2, x minus 2, which would be f of x equals x plus 4 squared, x minus 2 cubed. Oh, and I'm sorry, we completely forgot our negative sign, so let's put a negative out in front. Remember I said earlier, if we had an extra point, we could solve for what we call our a value, which we're not writing here. We can get our graph a little more accurate. But given the information here, this is the most accurate graph we could write. So remember, multiplicity of roots. Double root, we touch the x-axis. Triple root, we will still cross the x-axis, but you'll see this behavior where it kind of zigzags through. Before I let you go, I want to do one more example. This is our graph. So here I'd like you to pause the video and think about it and see if you can figure out what our answer here would be. How many roots we have and what exactly they are. Okay, so hopefully you've paused it, hopefully you've looked at it. Let's think about this. So, what do we know about our function? Well, Both of these are pointing up. We're decreasing to this point, increasing here. So we know this is even degree. Oh, I don't know what that is. We know we're positive because both are going up, so positive. And then this means we also have an even number of roots, which we know because we're at even degree. So what are our roots? Let's see. So here we have a root at -3, but we come down, we touch, we continue up. So this is a double root. So our roots are x equals -3 double root. Then our graph continues on and crosses at -1, but it just crosses normally. So we know we have a root at x equals -1. Our graph comes back down, comes up, and then it kind of does this zigzag like x cubed here. So we know we have another multiple root here. Here we're going to have a triple root. So then we have x equals 4 triple root. And then that covers all of our roots. If we look, so say you thought this was just a single root. Say you knew this is a double root, this is a single root, and say you thought this was a single root. Well, that would be, oh, never mind, that would be 4 roots. That would be, yeah, you'd still get an even number of roots. Ignore, sorry about that. I was wrong. So, if these are our roots, we can go ahead and write our equation. We have, this is a double root, that's a single root, so that's 3 roots, triple root, that brings us to 6 roots. Let's go ahead and write our equation. F of x equals x plus 3 for our double root, x plus 1 for our single root, x minus 4, x minus 4, x minus 4 for our triple root. She can simplify down to f of x equals x plus 3 squared times x plus 1 times x minus 4 cubed. And that's really it today. A big thing was multiplicity of roots. Remember, if we touch our x-axis, that's a double root. If we cross it in the same pattern as x cubed, that makes a triple root. There should be some practice available, just writing equations based on the graphs.